Hello, my name is Daniela Jones and I like going by Danny. I'm a research assistant professor in the Department of Biological and Agricultural Engineering at North Carolina State University. I also hold a joint faculty appointment with Idaho National Laboratory. Today, I'll talk with you about some of the online SAS tools that are also free for educators and students and are easy to use by anyone that is starting to manipulate and visualize big data. For this, I will use the billion-ton study, which is a report for biomass availability throughout the US. Some of the learning objectives for this session are to understand the various data types and variables in the BT16 database, apply structured query language or SQL to write data retrieval queries or edit data sets and evaluate the result set. Also, produce effective geographical visualization of biomass resources and infer some relationships between the variables in the data set. While this is a free online cloud-based software, you do have to create a SAS profile, and after that, you do have to register for the SAS On Demand for academics. Once you get your profile in, you're able to also get a SAS On Demand profile. This is specifically SAS On Demand for academics, and that's how you access this platform. You can select your own region. In my case, it's the United States. You have a cap for how much programs and data that you can have in this platform, but still, it's a good resource for anybody that wants to start. When SAS Studio opens up, you can see that there's 4 tabs: server, files, and folders, where you save all your files. If you want to go ahead and create a folder so that you can start organizing what you're doing, I created a folder named ASABE, and you can name it whichever name you want to name it. But now let's talk about the billion-ton study, the data that we're going to look at. The billion-ton study is a series of reports that went out every 5 years. The last one was in 2016. And what it does is a compilation of different runs for a specific econometric model called policies. This report is made by the US Department of Energy and run specifically by Oak Ridge National Lab. It's a good data set because it has different scenarios for different years, for different prices, in different feedstock of biomass, and there's information for every county in the United States. In our case, we will download the data for year 2022. This is a wizard to filter the big data set. I usually just skip this. I will go ahead and click on county data, and there it is. I'll just go ahead and cancel. Now, like I was saying, it's estimations of future projections of biomass. That includes agriculture, forestry, and waste. Under different scenarios that are laid out in here, there's different resource types or feedstock types, and for various different years and at different prices. For this session, I'll direct you guys to download year 2022. The only reason why I'm telling you guys let's do a smaller data set is just because we have a cap on the amount of data that we can upload to SAS Studio, the free version. So then you go ahead and click here, generate downloadable filtered data set as CSV. So that's going to take a couple of minutes. Well, I've already downloaded this, so I'm just going to go ahead and cancel. But once you have it in your download folder, you can upload it with this icon. You go ahead and go to wherever you have downloaded that file. You click on that CSV file. Make sure you unzip it before you do that. And in this case, it would be video. So you would normally click open here, but I'm going to cancel. So once you have it there, and I'm going to show you where it is. This is the .csv file. Open it and see that SAS automatically creates code generates code to import the file. So this is a .csv file, so it's not the preferred format for SAS. So it's really nice because you can copy this. This is already generated by SAS. You can copy this and create a new program. You can directly import that file. Now, I am going to suggest that we do a couple changes. Let's save this first as a, we're just going to call it ASABE. Now, like many other programming platforms, there's different file types. Oh, we want to save it here. There's different file types. This one, it's where you code. SAS calls it the program, and something like this, you can see the different icon here. This is a database, a SAS database, and this is what we imported, the .csv file. This out equals, we're going to change it to out.bt16 underscore 2022. And we're gonna do a couple more things in here. So we're creating the library called out that points to the this specific address. And this address, I got it from this particular folder. So we're just pointing the library to this folder, properties. To that, we'll add a couple more options. So you can go ahead and highlight this and then hit the running gap. Right now, because we changed the name of the output database, we're going to change it here, over here. So let's see. So if we open our database, so we can see here different variables in this database. The ones with the triangle or in the letter A are character variables like scenario. The ones with the circle and the numbers are numeric type. Now, for example, there are some variables that come as character, but I would expect them to be numeric. So something like yield, it's still a character. So this line says, copy this database and pasted it into a database with this name, a new database with this name. So we're just gonna do it, change the name so that we know it's a subset or a version of this file. And now we do to rename those variables that we talked about, like production, or in yield. I'm only gonna change production and yield. Perhaps you can ask your students change whatever you guys think should be a number from a character to a number. So okay, now every time you create a new one, it goes to the bottom. So now we have production, and you can use this structure to change all the other variables and ask your students to change whichever variables they think they want. So the reason why I downloaded the year 2022, it's because EPA, the Environmental Protection Agency, has set some targeted goals for producing greater than or equal to 60 billion liters or 16 billion gallons of cellulosic biofuels by year 2022. If we go by NREL studies, this particular report, add it through the ASIDS pathway, they predict that they estimate a fuel yield of 44.8, and that translates into 357,000 dry tons in year 2022. So what we can ask our students is at what price, based on the of the prices of the BT16, at what price will we be able to achieve that much dry tons and what type of feedstock, what combination of feedstock could we potentially use from the availability, the resource assessment by Oak Ridge National Lab. Okay, so understanding the various data types and variables in BT16. We went over a little bit, but I want to show you another little nice trick. So while you can ask your students to do it through code, you can also, if they're not as familiar with coding, you can also tell them, point them to the direction of the task and utilities in this platform, and particularly this data folder. It has that specific code that we call out. So here it is. This is where our Billington study is. Okay. So see how it easily generates the code for the proc contents. Go ahead and run that little guy. And it says, and it gives you again the list of variables and attributes and the metadata for this particular database. So once your students have gotten familiarized with the different data types and all the different columns or variables in the BT16, then they perhaps can start subsetting that data set. And this is where we apply some structured query language. And in SAS, you can either use SQL language, or you can use the data steps that we just went over. So if we go back to our code, as you remember, in production, there is instances where the value of some of the observations is null. So we can subset to not include where values equals to null. So we're expecting a lower number, 348,000. Okay, so now we have less observations, but in this case, all the production should have at least a value of 1 or more. So now that we have the variable production as a numeric value, we can start doing some statistical analysis. If you go to the task, then you can see there's a list. That's where we were earlier. You can ask your students to go ahead and explore the different task listed under the data folder, linear regression. Now, as I was saying, production, the production variable is the estimated dry tons for a particular feedstock. So let's go ahead and put that as a dependent variable. You can ask your students to figure out what are some of the independent variables that may be explaining the production estimates in the report or in the BT16. So as continued variables, so yield might be something that explains it. So let's go ahead and do that. Then see that this is not, it's still disabled, this run icon. So it is because in the next step, you do have to add it to this model effect. And as soon as you do that, then this little guy becomes enabled. You would expect that yield was a big predictor of the total production per counting. As you can see over here, it only explains 30% or 27% of the actual dependent variable. So you can start asking your students what else could be another variable that may predict this number. Or the, for example, biomass price, it's a good predictor. But let's go ahead and add it. You can add the biomass price to the model effects as well. And then there you have other options. You can change your confidence level, and over here you can add it as a forward selection. Run it. Remember that with the one variable it was 0.3. And now that we have two variables as predictors, we see, let's just quickly see the adjusted R square. We still have it. Okay, so that is because the econometric model policies is a little more complex than just simple linear regression. But hint, hint, the one feedstock that does have a better prediction with these two variables is miscanthus. Miscanthus production is seen in sees a lot more increase with increase in price, and it also has, in this case we're only doing year 2022, but if you see it over time, it also increases with time. So that could be, you could ask your students already, what about subsetting your big database into just the feedstock for miscanthus, and that in fact in the database it is called resource. Now if you want to go back to the data task, you can always do characterized data to figure out the unique values for a specific variable. Here we already have the database that we're looking at, out.bt16, the one that has the _1, which is the one that we edited. And you can see, I know that it is resource, but you can ask your students to figure out where do you find the different feedstocks. And so there you go. These are the different unique values for the variable called resource. Now, perhaps one of my favorite ones, the geographical visualization of these biomass resources. For this, you first have to merge your BT16 data with XY coordinates so that you can send that the XY coordinates information to some map data sets that are already in place in the SAS platform. Let's first subset our data into just the values for miscanthus, and let's pick a particular price, let's say 100. I went ahead and also added a filter for only land sources equivalent to crop, because miscanthus can be grown in cropland or pasture land. And we go ahead and run this. And there you go. Now we have 2,381 rows. And yeah, so you always have to sort the databases by the variable that you're gonna merge them by. This is a new data set that I have and I will provide as well. I am expecting to have a total of 3,109 rows because of the way I coded it. This is the same number as the amount of counties in the whole contiguous United States. Now we're ready for our new task, maps. We can go on Bubble Map, and it's pretty easy to go look at your library. We get the miscanthus data set. We're gonna do latitude and longitude. Latitude is my Y, longitude is my X. And then we're gonna do the bubble size in using the production variable. See how this guy is already ready. You can always change the appearance or any of the information in the map. Here's our results. Bubble maps for the east side of the US. That means miscanthus is expected to grow mainly on the east side of the US. Perhaps in this case, bubble maps does not necessarily reflect as an effective geographical visualization for this particular data set. So I have another code for you guys to look a lot nicer for the data that we want to look at. That way you can see not only that miscanthus is expected to be grown on the east of the United States, but also the darker colors represent something more on the lines of where the highest production of miscanthus would be. You guys can also guide your students to explore the different other graphs that are easily available in this platform. There's a link for a couple other sets of codes for different types of graphs. And that's all. Thank you so much for listening to my session, and I look forward to any questions that you guys may have.